up to this point, we haven't done any kind of work where we're combining two different objects, two different meshes with two unique centers. And everything up to this point has been simple cylindrical objects, extrusions, and inserting edge loops. Now I want to broaden a little bit and say, well, what if we had made something cylindrical like, and then we wanted to attach it to something planar or flat or box like? How would we do that? This is where you're really going to advance in your modeling, and and I and I swear by this. I think you're going to have an excellent boost in your ability to make things when you get a firm handle on how to combine and separate different objects at different times with different shapes at different angles. So let's start off with the simplest of them all so that we can get familiar with the tools, and then I'll little by little increase their complexity until we're finally making the toys, because the ultimate goal here is to build a toy and then be able to put all those parts together. So to do this, I've made a preset in my preferences so that this grid is a 10 by 10 with 10 by 10 divisions, and I have a cylinder that's preset to 8 sides. Specifically for this exercise, actually, I'm going to turn on the wireframe and show you the easiest way to get this cylinder attached to this plane as quickly and as simply and as cleanly as possible. In other words, clean meaning, what I mean by clean is that this cylinder will maintain its circular nature. It will be perfectly circular. So let's get to it. First things first, these two objects, this one has a center, this one has a center. Those two need to be combined down to one center. I'll even pull up the outliner so you can see we've got two separate objects. The magic tool is Mesh Combine, and there's nothing very complex about it. There's just the simple things here: merge UV sets, no merge for that, or merge by name, merging by name. And what we get is a little bit of garbage here in the outliner. A group with a transform node, another group with a transform node to sort of recall where your old objects were, and then a brand new poly surface with a new poly surface name, and we have one center. So they're still separated. There's a gap here, but they are in the same object. To clean up this garbage here in the outliner, you can simply delete the history, and now we're left with the object. This works well in my example because we have 1, 2, 3, 4 points. By the way, if you see that big bit of yellow, that's because soft selections is turned on. Just tap the B key to turn that off. B for boy. Just turn it off. And I also want all the polygons on the bottom here. And you're thinking, well, wait a minute, I've got 4 polygons here and I've got 8 polygons here. But what's critical here is not the polygon count, it's the point count. So on the perimeter I've got 8 points plus a ninth, and on the perimeter here I've got 8 points plus a ninth. So it's going to be a 9 to 9 point merge, and that's what matters. And that really does matter if you're going to use the bridge tool, which I am. And I'm going to go in the option box, and I'm going to make sure that it's linear, and I'm going to make sure I have no divisions. And I'm going to hit apply. And whammo, it's together. And now I can do other stuff to it, like if I want to make a button on a surface, or if I want to make a hole in the surface, all I need to do is simply push this up or down. So I'm going to select all the faces and translate this straight down, maybe even squeeze it in a little bit. So I'll control click on the y-axis, squeeze it in a little bit, shrink my selection, maybe move this down. And now I've got the beginnings of a perfect hole in my grid. And that is it. Making sure your point count matches, you can easily bring two objects together with a bridge. There's another pretty fast way to build cylinders straight from any polygon or set of polygons. The simplest being this: if I just have one polygon, frame that up, and I do an add division option box, and I do a triangular division, and then I do a quad division, and you get a circle. You take that circle and you extrude it, and there you have it. The downside to this, if you can consider it a downside, is that you have extra points right here. So that means this polygon, this one, and this one are n-gons. And depending on what you're making, that might be a problem. Or it might not be a problem at all. You'll just have to decide that given the project you're working on. Most of the time I don't like that. I like the result I got here, where everything connects very well and everything is a quadrangle except for the center. Take note though that these are quads at the pole. I could easily do that here by deleting every other triangle. I'm sorry, every other edge on the triangles. It's possible, like on a sphere, for example. If the sphere was 8 by 8, I'm on a slight tangent here, but bear with me. I think this is worth it. And then I went through and selected every other edge and hit delete on the keyboard. I can do delete on the keyboard this time because there's no points in between. You end up with quads, and it still looks nice. Keep that in mind. It's useful. Bit of a tangent, but a useful tangent. Okay, this one, I'm going to bring in another cylinder, same point count to keep things straightforward. I'm going to show you a different tool to use. I'm going to keep this really simple in this scenario because, well, it's just easier to show. But the point of showing you this next step, this next tool, is because you'll run into scenarios that are not as simple. And let me share with you what that is. So I'm going to delete those 4 and delete the ones underneath. And this time I'm going to use a new tool used for the first time in these videos, Append to Polygon tool. And Append to Polygon is simple to use. You simply click an edge to a parallel edge and it builds a polygon. And then you hit Y on the keyboard to start a new one. Edge to parallel edge, Y on the keyboard, and so on. Now, this is kind of like point-to-point modeling, and if you can avoid this, I would recommend it, but knowing how to do this is very good because sometimes you just have to do it this way. Sometimes there just is no other solution, and it's good to know how to build up polygons from an open edge. And there it is. And then I can continue doing the same thing I did over here. Now let's talk about what if the cylinder, what if the grid, what if the point count was different between the cylinder and the grid. Let's keep this different but still simple. This time the cylinder, I'll give it 10 sides. So I've got a couple more points to deal with. So what does that mean? That means a bridge isn't going to work because bridge requires an exact point count match. So I'm left with the append to polygon solution. So there's that. So if you have a high polygon to a low polygon connection that you're trying to make, like attaching a high polygon hand to a low polygon wrist or something else, and they happen more often than not. Even if you're working on teams too, different people may have different poly counts and you'll have to make corrections. Knowing how to adjust for those is very handy. So in this case, I need to make a decision on where my triangle is going to be because that's the only solution I have, or where are my n-gons going to be? That's my other solution. Both solutions aren't the best, but they do solve connecting a high poly to a low poly situation. So I'm going to do the append to polygon strategy where I'm going to delete those polygons and delete those 4 underneath it. make sure I combine my meshes or else this isn't going to work. Take both of them and combine them. Might as well delete the history while I'm here. Clean up the outliner and get to work on my append to polygon. I'm going to do the quads first. I think they're easier to deal with. So I'm going to hit my append to polygon tool and go edge to parallel edge. Hit Y to repeat. I'm going to skip this area. That's going to be my triangle. Edge to parallel edge. And then edge to adjacent edge. And then hit Y. So that's how I fit the triangle in there. I can do the same thing on the other side. Edge to parallel edge. Y. And then edge to adjacent edge right there. And the others are quads, which are easy to visualize. Sometimes that happens. Just hit undo. Try again. Hit Y. You really do have to click right on the edge, otherwise you end up with something bogus. And then enter to finish that tool. And now I have a connection. It is a clean connection, and to deal with this triangle, let's talk about that, because I do think it's a problem, but it's a problem I can work with. So what I'm going to do is tuck this down in the surface slightly, and maybe squeeze it in slightly so I can see the triangles. I would like this triangle to not drastically damage or interfere with the quality of my edges, and it could. If you're going to have triangles in your mesh, keep them small and keep them flat. So that means I'm going to swap to the front view here and make sure that this is flat, or at least as flat as I can make it, if not exact. Like that. Maybe a little bit more exact. Like that, okay? Now it's as flat as it can be, and it's as small as it can possibly be in this situation. So the next step is to take my selection and extrude it. So I'm going to extrude the entire appendage and offset the entire appendage and squeeze it in. So there's a poly loop separation between where the hole is going to be and where that triangle is going to be. So then I'll just translate this whole thing down into the surface. Maybe squeeze it in a little bit more just so you can see what I'm doing. So there it is. And then let's just shrink my selection so this thing isn't so absurd. Tuck that down. Okay, so it's easier to look at. And now when I hit number 3 for subdivision surfaces, just check out how clean, and I'll turn off the wireframe, check out how clean that is right there. It's just absolutely gorgeous clean. There's no little bumps, there's no little divots, and I was able to get a high to low poly connection. If this triangle lived here, you would see like little creases, and you can try that out for yourself. Maybe I can force it. Maybe I can force it so you can see it. I'll select the edge and delete it properly, and then go to object mode. It's very slight. I don't even know if it's going to show up in the capture, but it's very slight. I see it. I find it to be an annoyance, and it would probably cause, I can almost guarantee it would cause some stretching in the textures in this area. So I would say keep them small, keep them flat, and keep a polygon loop spacer between them, between your detail areas, something like that, and something like that. Very clean. I love it. Okay, I'll see you in another one if I can think of another example. And I just noticed one more thing I want to focus on, those triangles. Let me frame this up. And notice how the triangle is on the breaking point going into this hole here. I would like this polygon spacer to be flush with that triangle, and then you will have no problems, particularly if this were an organic solution, organic mesh, but really important to it, super close-up product rendering. I think that triangle on the edge is going to be a problem. So what I'll do to get a perfectly flush poly loop next to that triangle is to take the entire selection, this entire selection here, and extrude it, and then offset it and maybe not offset. Offset's not giving me what I want. Let's just scale it in globally. Control clicking on the y-axis and just squeeze that in just like that. And it doesn't have to be very big. And that's nice because it gives me my 3 edge rule, keeps the triangle off the corner. Flawless. Very nice. Very clean. That's the right way to do it. Earlier I mentioned high to low poly transitions. I have 3 basic strategies I like to keep to and share with you, and I think you can elaborate on these 3 depending on the model, but it's basically it gets narrowed down to these 3. And let me illustrate them for you. It's basically going to be a 2 to 1 transition, or a 3 to 1 transition, or a 2 to 4 transition. This one is very, very, very common in character modeling or just any kind of organic like plant and dog creature characters, things like that. This one, the 2 to 1, is your most basic, and we've already seen it at your triangle. 2 edges flowing into 1 edge. A 3 to 1 looks like a triangle, except it has that 4th edge, or that 4th point at the center of the triangle. This one I use on characters, or maybe I used to use on characters, but I try to avoid these 2 like the plague. Not so much of a big deal on flat surfaces. Like I said earlier, triangles are okay in flat areas, but it's on the curvy surfaces where these 2 transitions can cause problems. The 2 to 4 is probably your best for organic because and amazingly, we've already been doing it. It's basically an extrusion with an offset. But if you didn't extrude and you want to force an extrusion, you can create it here. So here's that poly loop of the offset. It goes in this direction. So to see those in Maya, let's say I want to transition this higher area just down to a couple of edges. I could simply use the merge vertex tool and just drag and drop point to point, and they just snap together. And now I have a simple 2 to 1 transition. And it does delete the former point when you combine them like that. So that's exactly what merge is doing. A 3 to 1, so let's take these 3 edges coming in and force them down to 1, would be something as simple as this. And then you would remove this edge right here. So you have a quad, and I can just hit the delete key on the keyboard because there's no points on that edge. So those 2 are reasonable. And then the 4, so here's what I mean. So let's take this edge right here. So I've got 1, 2, 3, 4 points. I'll tuck this edge up. And then you can visualize a polygon right here. And that's the append to polygon tool. And just fill in the gap, edge to parallel edge. And now I've got a transition, and I've just forced a loop. So I could take that edge, extrude it. I haven't done extruding of edges until right now. It only works on open edges. But there you go. There's your transition. And like I said earlier, it does create a loop. We did force a loop. So I can come in here with the insert edge loop tool and drop in supporting edges or continue splitting and do whatever work that needs to be done. In the next section, we'll look at another yet slightly more complex merge of objects. The next kind of combining is very important and can be very sloppy, and a lot of people mess it up. It's called Booleans, and there is a right way to do this. In previous combinations that I've shown you, point count was very important. Even in a high to low poly situation, you still had to kind of keep track of where your edges are going to flow. And Booleans, it's no exception, and sometimes it's even worse. I think a lot of people will use a Boolean to shortcut the creation of complex objects, and in the end you just end up with garbage. And you're much better off taking your time, keeping track of your points. So let's show you a garbage version where I'm going to take this sphere and I'm going to cut into this cube with it using a Boolean. And this is basically what they're good for. Be able to get complex shapes. Let's see here. I think maybe a union will combine them together, so it's like it's as if they had deleted the interior of that space, so that's useful to know. I'm just going to hit Z to undo. Intersection, I think, is what I'm looking for. And so that's going to be the volume on the inside of the intersecting space, and then difference is going to cut based on whichever one was selected last. So in this case, the cube cut into the sphere, and if I select it the other way, the sphere cuts into the cube. So the direction of which you selected is very important. So now that you know that, union, difference, intersection, that's all very cool. But what you end up with are these garbage polygons, these n-gons. N-gon meaning greater than 4 points. In math, an n-gon means n stands for a number. But in the 3D modeling world, n means greater than 4. So these n-gons are a problem, particularly for organic modeling. I suppose if this is all you needed, then like for a previs, then you can get away with it. But to me, this isn't good enough. So what I really want to do is give you an example that I know works and that I've done a few times. That's between a sphere and a cylinder. I want to cut a pipe at an arbitrary angle running through this sphere. So the way for me to determine that is to figure out how big the radius I want to be of this cylinder, and determine just exactly where it's going to cut through based on the point count. So let me just shrink down the radius. Use my virtual slider, and I will rotate this object, increase its height. Let's give it like a height of 3, and rotate the object on X. Also turn on the wireframe unshaded. So I'm going to rotate this until this cylinder intersects where at least one or more of the edges can connect. So I have like a flow from this edge into this edge, and then I can visualize that from here to here I can draw another edge and get a good connection. Also, that this cylinder resides within the boundaries of the same point count. So this cylinder has 8 points on its perimeter, a 9th in the center. So this 4 polygon selection here has 8 on the perimeter and a 9th at the center. That's very useful. So now I can play with the radius a bit as long as it fits within that set, and I can play with the rotation and choose different places to cut, but as long as it's always within that set of 4 polygons. And if I needed to be more precise, I can increase the density of the sphere, and then likewise for the cylinder if I need to. So for this example, I'm going to go with this angle, which is about 35 something, 35.8 something, and maybe adjust that, refine that a little bit so that this edge and this edge are very, very close. And the reason for that, I'm just going to eyeball it, just close. Yeah, there we go. And the reason for that is so that I can preserve this contour right here. So that's really the beauty of using the Boolean, is I can preserve the geometric contours of simple geometric shapes. And that's usually when I pull out the Boolean tool and I say, okay, I can't solve this with any kind of eyeballing or organic modeling. I need something that's kind of sort of close to solid modeling, even though this is a far cry from solid modeling. But there are good practices in doing this. So I want to punch a hole through this and keep the arrow. Open up my outliner with this viewport preset, and I'm going to duplicate my cylinder. Excuse me. Control D. And I'm going to hide that cylinder so I can use it later. So Control H to hide it. And you can see it's been ghosted out in a dark gray. Then I'm going to take the sphere and cylinder, and I'm going to hit the difference button. And that is going to punch a hole through the sphere, which is pretty cool. And you can use that for just about anything. And now I want to draw some edges in here. I want to make sure these points right here are merged. I'm going to use the merge tool to solve that. And then I'm going to add in insert some edge loops. The next step is to draw edges from here, from this point to that point, here to here, here to here, and here to here. And to do that, I'm going to use the interactive split tool. And what it does is it automatically snaps to a point. You can actually just briefly take a look at this option box, and you can see that there's this tolerance right here. If you were to drag that tolerance all the way down, you could basically have like a free point. It'll snap to edges, but it freely floats around. Not too useful for me right now because I do want it to be point accurate. So by having that tolerance set to 2, it will grab those points. And the snap magnets, that's a divider. That's a proportional divider from this point to this point on this edge. It divides it once, and you see how it automatically snaps to the center. And if you increase that number, you can get multiple points along that path, along that edge to cut on. Alright, just so you know. I don't need it. I'm going to use the defaults. So point to point, and I'm going to hit enter to finish that, and I'm going to hit Y to start another one, and then hit Y to start another one, hit Y to start another one, and then enter to finish. And sometimes it does jump like that right there. I do have a small solution. I'm going to draw past it and then hit enter to finish, and it still does jump. I'm not entirely sure why that's happening, and it is buggy like I said earlier. Okay, so I can't draw the edge in there, so I'm going to do an alternative. What I'm going to do is, and I really don't know why the edge won't draw in there, but I've got other solutions. What I'm going to do is do what I can to the other side. So let's repeat that over here. And I'm going to use the append to polygon tool. What I'm going to do is just delete this thing and use the append to polygon tool to finish it. And that's a reasonable solution as well. So interactive split. Let's see how many of these I can get. That's good. That one's good. That one's good. And we have winners all down here. So I just can't get that one. Just that one that won't go. So let's get these points to come together right here. I'm going to use the merge vertex tool and snap those together. And snap those together. Pop back over to the other side. Do the same thing over here. Snap those together. There we go. And there we go. And I'll hit Q to drop out of that tool. I'm going to delete this polygon since the interactive split won't do what I want it to do, and I'm going to use the append to polygon tool to fill in the hole. So, you know, not the solution I was looking for this exercise, but it is going to do the job. Brilliant. Okay, so now, if all went well, I should be able to shift double click this polygon and get the whole ring. And it did. That's great. So that tells me that I don't have any stray points. That tells me that I don't have any n-gons, because polyloop selections will not work on n-gons, as I've said in earlier videos. So I'm going to use the insert edge loop tool, and actually no, scratch that. I'm going to use the bevel tool. So I'll hit Q to drop out of that. Let me select this edge right here, double clicking it, nice clean ring, and I'm going to bevel it. I'll do the same thing to the other side. And let's use the hotbox recent commands bevel. There we go. Okay, so now when I hit number 3, I get a very clean organic surface. Let me turn off the wireframe to take a look at it. It's a nice clean hole punching through, and I still have the original rod to punch through it, and that's going to be a Shift H to unhide it. And let's also drop a bevel at the end of that, just for the sake of cleanliness, and also recent commands bevel. So number 3 on that, and I've got my rod punching through the cylinder, and now I have the option to use the pole to do something else with, maybe a globe standing on a bookshelf or whatnot. Okay, for this one I'm going to show you how to cut at an arbitrary angle and an exact angles. This is to assume that someone's giving you a set of drawings, you don't know what the angles are, and all you have are line drawings to follow. So we've got a cylinder and a grid, And I'm going to go to the side view here. I'll hit number 5, and I'm going to rotate this grid at an arbitrary angle and treat it as if it's some kind of line in my drawing. Let's turn on the wireframe on shaded so I can see this line. The way this works in the less accurate way is to use the cut faces tool. So I'm going to select the object I want to cut and get the edit mesh cut faces tool. The reason this thing is less accurate is because I can't snap to the grid or to the points when I'm using this particular tool. All I can do is just click and drag, and it's to the best of my ability to click. And you can see here I didn't even click very well in my placement, and I'm using the opposite end of the moving my cursor to the opposite end of the cut in order to kind of get leverage on the angle. So it's very hard to get that just right. So there's a better way. A very accurate way, I should say. That's more of a free flow cutting kind of tool. But if you need to be precise, there's a better way, and that is the projected curve on mesh and split mesh with projected curve tools. These two were introduced, I think, in version 2012. Maybe it was 2011, but it's a welcomed addition for accurate cutting. So what you need is a curve, and in this case I need a curve, and I need it to be linear. So I'm going to go to the option box. The default is 3 cubic. If you hit the reset tool, it's 3 cubic. I want it to be 1 linear, so make sure it's on 1 linear. And I can, of course, snap to points when I'm cutting with a curve. So you can see I can snap to any point here on the plane. And if I'm snapping to the grid, I could just hold X for that. But right now I'm holding V, snapping to that point. I'm going to snap to the opposite end, and then hit Enter to finish that curve. And you can see here in the outliner I've got a brand new curve, and there it is, nice and straight. And I'm going to select the cylinder, and then in the outliner, it's easier to select it in the outliner. Control click, or on a Macintosh, Apple click the curve to add it to your selection, and go under Edit Mesh and choose Project Curve on Mesh. And what you get is this brand new curve. Oh yeah, that's right. The other thing is it's very sensitive to the viewport you're looking at. It projects it at the angle you're looking at the object. So it's important that I'm actually in the orthogonal viewport, so the side viewport in this case. So I'm going to select the cylinder, control click the curve, edit mesh, project curve on mesh, and now I've got a curve on that mesh. It does add extra points. You can see these extra points to help it interpolate properly. I'm going to click the cylinder and then control click the projected curve, go to edit mesh and choose to split it to actually get the cut. And now I have the bottom half completely separate, and I can select it and delete it. And then I have some extra points that have been created around the perimeter due to the extra points that were interpolated on that curve. So I'm going to hide the curve, Control H for the other curve as well. And let's also hide the plane just so it's not in my way. I'm going to go to Vertex and go through and just remove all of those extra vertices. I wish there was a way where this could be a little cleaner, but for some reason it needs these in order for it to calculate it. It's easy enough on simple objects to delete them. So I will go to the polygon plane and unhide it, and now I can go through the process of connecting it. And in this scenario, all you need to do is give a little space to the edges, get these out of the way, and I'm going to translate them based on object space or normal average. Both will work in this case because the object has been rotated. It'll work with object space. Just get these out of the way. And again, I can be more accurate, more careful in that placement by selecting both of these and scaling them apart so they're evenly spaced. I could do that too. And then I'll just delete these 4 faces here. Notice I haven't moved this object at all, the chimney object. I'll select both of those and I'll combine them. Once they're combined, go through with the Append to Polygon tool and then do whatever finishing needs to be done. I don't think I need to go any further from here for you. I think you have a pretty good idea on what to do from all the other examples. So let's get on to the next section. So before I get to the Monopoly house and the chimney on the Monopoly house, I want to talk about and show you with an illustration I've done of a gambrel roof and barn. Because I once years ago ran into a situation where I needed to create some little piece of architecture, and I had the time of my life trying to figure out a way to do it efficiently, and I did manage to find a way. So I'd like to share that with you. So I did this little illustration here. I'm going to adjust it so that the drawing roughly matches the grid, like I normally do. And make sure the grid's on top, and then just move this over so that the drawing matches. And what I'm going to do next is to draw a single polygon and solve this problem two-dimensionally, and then thicken it and solve it from there three-dimensionally. So I guess what I make this a point of showing this to you is that there have been many times where I simply couldn't solve a problem with just primitive and extruding it and changing its shape and adding edges. Sometimes I just have to go back to my drawing skills and solve things with lines and two-dimensionally. So this is the solution I have. And that tool is the Create Polygon tool. So it's different from the Append to Polygon tool. It does make polygons, but the Append to Polygon will fill in on an open edge on an existing mesh. So this one will create an entirely new object. And I can hold down X to snap to the grid, and something like that. And we'll just approximate the image. And then hit enter to finish it. So here we have the item, and I'll just adjust the vertices a bit to match the drawing. Take those two and scale them away from each other. And from here, going to a perspective view and hitting number 5, you can see I just have a broad, flat polygon, and now I can select that face or object and extrude it. So I'll select the face and extrude it, and then move it on its positive direction of local Z so that the normals don't flip inside out. And I've got myself the beginnings of a roof, or maybe a low polygon piece, or I could keep it narrow. Let's say I did want to make the trusses or the 2x6s to build this. I could then take the faces, both back and front, and extrude them again and offset it a set amount. So that makes a perfect frame. And what's really cool is that all of these angles here, this angle, this angle, and this angle, all 5 would add up to 180 degrees if I had built this properly. I can adjust the thickness of it. I'll just grow my selection and translate my selection, so I can adjust the width of it. And then I can take these two faces and bridge them together. Again, it's going to be a linear bridge, and there should be a problem when I do this. Yeah. So what happened is it twisted it. You can see it didn't quite connect straight across. And there's a little solution for that someone from Intel helped me figure out. That is to invert the polygons, reverse the entire object, and then run the bridge. And it gets perfectly straight across, and then just reverse the object again. So all the normals are facing the right way, the correct way. And that's pretty much it. And then from here I could duplicate it and maybe move it forward a couple of couple of units, however far it needs to be spaced, and then hit Shift D, and you've got yourself the makings of for a building. That's basically the piece that we're going to use for making the Monopoly house. So we'll go on to that next. And now we're going to make the Monopoly house. I'm going to import the image into the front viewport. And I've got this simple layout. I managed to find this on a Google search. And I'm going to move this thing to the center. Reduce the gain. And adjust it on the X. Drop the grid behind it. Just zoom in here. See if I can center it up a little bit better. That's pretty good. And just move it up on the y-axis. There we go. So it's on the ground. So I've done this before many times in class. I've used this reference one quite a bit. And the simplest version of creating this is with the Create Polygon tool. And I'll snap to the grid matching this shape and extrude it. And then also extrude the roof out of that. And then we can attach the chimney. I'll just go through that really quickly here for you. I'm just snapping to the corners, and the only big deal here you need to keep in mind is to do this clockwise. You could do it counterclockwise, but clockwise so that the polygon normal is facing me. And then when I hit enter, it finishes the polygon, and if I go here to the perspective view, you can see I have this large n-gon. And normally I don't want to work with n-gons, but for the sake of time, I'll give you this simple one, and then I'll go into a more complex one. This is going to be extruded, the polygon. Pull forward on the z-axis so that the polygons don't flip inside out. And I can hold down X to snap to different grid units to get a specific length of the house. For the roof, I can take these two faces right here and extrude them. And in this case, the thickness parameter is going to work out well for me. Just hold down Control to get better numbers, and then I can take say like that polygon right there and that polygon and extrude those and just translate them on their local Z space, something like that. And there you have it. There's pretty much the basics of getting that piece as one unit. So I want to do it again, and this time I'm going to be a little bit more detailed. I'm going to have quads all around, large splits on this triangle, basically much more so that I can have the option later on to embellish it further and make it easier to also attach the chimney. For this particular house right now, just so that you know, I could insert edge loops. I set the insert edge loop to multiple, and I have a dividing of about 8. It was based on the number of units I pulled forward, 1, 2, 3, 4, 5, 6, 7, 8. And then I just split it like that. And that gave me a reasonable number of divisions to connect to. But you can see that when I split horizontally, I end up making this n-gon even more crazy. So I don't even think in a game situation that this would be acceptable. I don't know, maybe it is. Maybe in a really low poly situation this polygon's acceptable, but I really don't think so. At least I'm just not particularly happy with it. That's why I'm going to go back and do it again. So let's just hide this guy. Control H and go back to the front view. Get the Create Polygon tool once again, and then I'm going to rebuild this piece. So this time what I'm going to do is snap to every single point along the perimeter on the grid. So every single grid point. So let's do that. So I'm going to hold down X and go through each one. I'm just holding down X. I'm going to skip those and go straight for the peak. And then continue adding them, even though it looks like the polygon's finished, continue adding those points right to that last one and then hit enter. Okay, so what does that do? That gives me vertices to work with along the perimeter that I can then use the interactive split tool to cut across that. So that's what I'm going to do next. And I just want to change the color of this polygon. I know most people don't mess with the default shader, but I'm just going to change the color a little bit so it's easier to see. There you go. And now I'm going to use the interactive split. And first I'm going to cut across here and hit enter to get that cut. And then I'm going to split following my grid points all the way to the top. And it should snap right in there, and then when you hit enter, it'll automatically add that point right there. Let's go across. Grab that one. Do it again here. Now by the time I'm done with this, you'll be saying to yourself, oh, I could do that so much faster with a box. And it's true, with this very simple object, you probably could. The reason I'm going through the trouble of doing this is not because this is the only way to create this object. It's because I want to share with you these tools. I want to share with you that there are some situations that require you to solve problems with drawing, with 2D, and maybe not all of you need it. I know that occasionally I do. So let's look at our points now. It's looking pretty good. So I'm going to cut across here. I need one right down the center. And then it should be easier to cut this point right here. So since I've got two grid points here, but the interactive split tool wants to find, so if I reset the tool here, it wants to find the midpoint. You see? So if your tool has been reset and Snap Magnets is set to 1, it wants to find the 50% point between here and here. So if you change that number to, say, 2, and then hit tab, it now wants to find 2 points. And you see how it automatically snaps right there? That's pretty handy. So now I can just click and hit G to make a new one. There we go. And now you see, because I've divided the distance, it wants to split twice. So let's change that number back to 1. Hit tab. And now we go back. Just go all the way to the bottom in this one. There we go. Pretty nice, I think. Took me a little bit to figure that out. I got it though. And that back to 1, hit tab. Tab so that it knows that you've changed those numbers. Okay, and then to get these vertical lines that I'm looking for to show up on the turn on my wireframe here so I can see them. Turn off the grid for a moment. I want these verticals to come right up into this area, so I want to divide this edge 3 times. So when I turn on the interactive split tool, the default, just resetting it to 1, I can split the halfway point and then split that one halfway and then split this one halfway. So you see how that works? So when I added this edge right here earlier, it actually just threw everything off in terms of taking advantage of the default settings for this. And if I had been more careful earlier, I could have easily added those myself. So what I'm going to do is, easily is to take this edge and delete it, and then also go to vertex and delete that extra vertex that I had added. So if you had done that, make sure you take out that vertex if you were following along with me. Okay, and then back to the interactive split tool. Again, taking advantage of the default settings, let's do the 50% point first. And then finally the these last bits. So there it is. I like it. It's very nice. And then I can go a little further with the extrusions. So let's do that next. So let's go to object mode and hit Q to drop out of that tool. In object mode, let's extrude the whole object and translate it forward. Let's translate it forward 8 units, so let's count those out. And I'm going to hold down X. So 2, 3, 4, 5, 6, 7, and 8. This time around, I want to make the roof separate. So I'm going to select the faces of the roof and make sure that's the only thing I have selected. And I'm going to duplicate those faces. By the way, before I do that, you guys see the box now? I mean, if I had known that this is what I was going to make, with the exception of this angle right here, I mean, it is just a box extruded. But honestly, there was a time when I simply just couldn't see it from a box, and I could only see it from a drawing. And if you're an architect or a former architect, or if you work with architects and they give you drawings, even if you're in character design and people give you character design, sometimes it really is challenging to visualize something as a form if you don't regularly do that. So that's why I find it handy to know what these tools are. Anyway, back to where I was, duplicating the faces. That makes a new object, which we can see in the outliner. And that object selected, I'm going to also extrude it. And for this one, I am going to use the thickness parameter for the reason that local translate Z tends to do that, where it makes this kind of arced surface because it's moving each polygon according to their polynormal, whereas thickness, it's much more rigid and it serves me better for this piece of architecture, so it just moves them straight out and it preserves that thickness all the way around, which is very handy. Then I'm going to move this face and this face downward. If we look back at the drawing, the eaves kind of come outward, overhang a little bit, and then they're also cut at this angle. So I want to move those down and then cut them at that angle. To do that, I'm going to use the transform component tool to move them, and I can move them on their local Z. So I'm just going to move them all the way down past the cut point, and then to cut them, I'm not going to use the cut faces tool. It's not accurate enough. I'm trying to be very tight with this. So in this time, I'm going to use the project curve on mesh tool. Project curve on mesh tool will require, to make a straight cut, will require me to use a linear curve. So I'm going to get the CV curve tool in the option box. And by default, it's set to 3 cubic. What you want to do is set it to 1 linear. Just close that. And then you're going to hold down X and snap right where you want to start the cut, and then end the cut over here, holding down X, click again. So that's a 2-point straight curve, and then hit enter to finish that curve, and you can see the curve right here. Then what you're going to do is select the object that you want to cut, and then hold Control. If you're on a Macintosh, hold Apple in the outliner and select the curve. And then go to Edit Mesh and project it on the mesh. So what happens is that there's this new curve that's been created that's actually attached to the mesh, and you can see it in the perspective view. And there's a couple of extra points that get added. This one, this one. For some reason, the tool needs that to interpolate the cut. That's why I didn't add my 8 divisions across the roof yet, because I knew that this linear curve would add these extra points, and with 8 divisions running across, it ends up adding like 100 new points that I have to go through and delete one by one because I already tried it that way. To actually make the cut, because the cut hasn't happened yet, you're going to select the mesh again, and then you're going to control click in the outliner the curve that's been projected, or Apple click it if you're on the Mac, and you're going to go to Edit Mesh and choose Split Mesh with projected curve. And in the option box, there is an option to, if I reset this, it's just set to split it, but there is an option to split and detach. I tried it. It didn't do anything, but it did split it. Um, and what happens is in face mode, if you just pop back over to say the front view and just marquee over that section, you can see it did lop it off. And I'll hold shift and grab this section too, and then go back to perspective so you can see it. So you see it did section that off for me, and I've got a perfect straight cut going across that. So I'm just going to hit delete and get rid of that. And then I just need to fill the hole with the append to polygon tool. But before I do that, I need to get rid of these stray points that were created. So I'm going to hide the projected curve, Control H, hide the original cut curve, Control H, select my roof and go to vertex mode, and you can see these stray points right here. So they've got one here and here. Let's just hit number 4 so I can see through it. I've got 2 right there. I've got a couple right here and here. It's a lot easier to clean this up before doing the divisions. And then with those selected, just hit delete on your keyboard. And those points are now gone, and now it's really, really easy to append the polygon. So back to shaded view, number 5, and then append the polygon. And edge to parallel edge. Enter. Just like that. Y for a new one, and enter again. Awesome. So now it's going to be really, really, really easy to add those divisions. So let's go get the insert edge loop tool, option box. I've already got it set to 8, so let's just cut across, boom, just like that. And I don't need any more horizontally either, by the way, because these cuts that I made, which are aligned perfectly, give me, as I've already tested earlier, give me the exact amount of divisions I need to add the chimney. So let's get the chimney. Let's just minimize this stuff. A cylinder, I'm sorry, moment there where I wasn't thinking. So a cylinder, and bring that into the scene. And let's go to the front view to see where we need to put that. Something like that. And then let's change the radius. Let's use the slow virtual slider so I can get tighter numbers. Okay, that's decent. Tuck it in the surface like so. Maybe make it a little taller. Let's make it just slightly higher than the peak of the roof. Alright, and then just like the last cut I did, I'm going to use a straight curve. So I'm going to get a create CV curve, make sure it's linear, and I'm going to snap to 2 different points this time, not the grid. So I'm going to hold down V on my keyboard, 2 points, and then hit enter to finish that curve. So here's my new curve. I'm going to select the mesh I want to cut. I should say the mesh I want to project the curve to. Control click the curve, edit mesh, and project. Select the mesh again. Control click the projection curve again. Edit mesh, and split mesh with projected curve. So now I can go to polygons. Let's hit number 4 so we can see through everything. Select the bottom half. Delete it. I'm just going to hide the house so that I can work with and hide the curves. So I can just work with the chimney right where it is. And that's going to be much more accurate. Alright, let's unhide the house. So select that, Shift H. Number 5. Alright, so it's right where it needs to be, which is just lovely, really. With the exception that, like this edge isn't quite lined up with that one. I can live with that. I could slide it this way a little. What is that? On the Z-axis, just a little bit, because that won't hurt anything. The roof selected and the chimney selected. Oh, of course, make a decision of just exactly where you want this chimney. Maybe back here would be more attractive, not centered in the house. I guess ultimately it doesn't matter, but maybe something like right here would be more attractive. And then the chimney, the roof selected, mesh, combine. Let's remove those 4 right there, and just hit number 4 and make sure I didn't accidentally grab any others. Hit delete. And number 5 again, and append the polygon to fill in these gaps, to fill in these holes, and then hit Y to start a new polygon. It's coming out pretty good. I really like this one. I like this one because this version of the house because it gives me an opportunity to add in and embellish details like I could add windows and doors and all kinds of fun things. It's easier to texture. You really won't have any texture stretching problems. No end guns, and you can bet your butt that this object would be accepted by a game engine. You know, this could be very easily triangulated in a game engine. Um, Much easier to manage, and it's all quads too. So that even this large triangle that was here earlier, it's cut up in quads. Oh, I guess I have triangles right here. So I guess I have some triangles, but really not a big deal. And then of course I could cut, you know, the house this away. I really can't think of anything particular right now for that. I could definitely go in here and add supporting edges to sharpen up the roof, and then maybe handle all the corners with a bevel, and then turn on subdivision surfaces. I think you can handle that stuff. You don't need me for that. That should wrap everything up for the Monopoly house. I'm very happy with how this came out.